let us discuss about few tools, right, for designing a mathematical model. Tools in the sense like it is not a software tool or something like that, but we are using the basic idea about, let's say, mathematics and physics we have already studied in the schools, right? Schooling, no? So we are going to use that. Okay. Let us start with dimensions and units. Okay. So dimensions and units. What do you mean by dimensions and units first? So dimensions means, say for example, let us say, let me do one thing. I'll take the Jamboard of it. So go back. Let me take the whiteboard. Okay. Okay. So let us take. So if you want to calculate the area of this, right? If you want to calculate the area of this. So what is the area of this particular thing? Area is equal to length into, right, breadth. Right. This is what the basic thing we all know about it. Okay. If you want to calculate the dimension of it, then what will be the thing, right? So here, if you want to calculate the dimension, you will be represented in square bracket, right? That is A is equal to length means it is length, okay, and breadth also what it is also another length, right? So I make it as L, so which is called as L square. Okay, you may be asking, sir, how it is actually L and L, right? So there is a concept called dimension analysis, which we have already studied in our schoolings, I hope. Okay, dimension analysis. Okay, dimension analysis. Okay, fine. So this is what your thing. Okay, fine. So here, what actually you're doing is that this is what the actual formula of it. But what you are doing is that you are converting into, or you are deriving this formula into a, what is that? I mean, you are converting the physical quantities into a derived units. Let's say two things are there, right? Let me show you that. Right. So what actually I have discussed is that you are going to identify the area of this. Is it right? This is the length and this is breadth. Okay. We are going to identify the area of it. I'll do one thing. Let me remove everything and let me remove everything. Fine. So here, what actually I'm going to do is that we are going to identify the area of it. So area is area of this is A is equal to length into breadth. That's what I told. So length can be represented as L and breadth can be also represented as L. So this will be finally L square, right? So what is A actually I told? This is the dimension of A. Dimension of A will be L square. What do you mean by this actually? Okay. So dimension means you are converting the fundamental or primary quantities into a derived quantities, right? That is the fundamental quantities. What are the fundamental quantities? Let me say fundamental quantities are uh, length, right? Length, mass, and time. Okay, temperature is there. A few things are there. That is fundamental quantities, right? Or uh, let's say, or primary quantities, right? Primary quantities. Okay. 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 So whatever equation, whatever formula is there, you are converting that into a derived quantities with the help of the fundamental quantities, right? So, for example, let us say this particular case, you can take this, right? What you are doing is that this is actually the formula for force, but it is somewhat different. Why? Because your what is the formula for that force? Force is equal to mass into acceleration, I hope. Okay. So if you're taking acceleration, right, what is acceleration? Change in what is that? Length by change in time, is it right? So what actually you are doing is that you are using that m into L by T, right? That is, this is your dimension quality, I mean dimension of this particular force. Okay. So acceleration, you are converting that into the basic quantities or the primary quantities: length, mass, time, temperature, etc., right? These are the basic quantities. What actually you are doing is that you are converting that into a derived quantities. Okay. So you have the force, right? You have the force, or let us say we have discussed about that this one, right? You have the area of this particular object, right? How you are converting that area of the particular object? You are converting that area of particular object into a, what is that, derived quantities, or say dimension analysis, right? This is what you have, dimension analysis, right? Finally, what actually you are doing is that you are proving the homogeneity. What is that homogeneity? That is the what is that, the content, or the unit of this left hand side should be equal to the right hand side of it. Say for example, in this case, force, what is the unit of force? Is Newton, right? So Newton is equal to mass into length by time square. So it means that the left hand side should be equal to the right hand side. That is what you are proving, that it is dimensionally homogeneous, right? So with the help of this, what actually you are doing is that you are checking whether the physical dimensions in the design. Okay. So next we are going to see is that the physical dimensions in design. Okay. So in this particular number of significant figure, right? What actually we are trying to say is that uh, our significant figures should be precise, right? Say for example, let us take this particular case, 5400. This is the measurement, and the significant figures, which is to be represented as mathematical model, right? It is 2, 3, or 4. They have mentioned it. It is not clear actually. The assessment, it is not clear because, but ultimately the values are same. 554 into 10 to 10 raised to 2 means what? 5400 is correct. 540 in 10 raised to 1 is, of course, it is also correct. 5400, and this is also, but everything is fine, but the assessment is not clear. I'll tell you why. The reason, let us take an example. Let's take an example. Let me remove everything. So let us take an example. That is, what I'm going to do is that I'm going to create a test, right? I'm going to create a test for a particular solution. I'm going to make a test. Okay. So the test will be, say I'm going to do 10 number of tests. Okay, I'm going to give 10 number of tests where I'll be getting three outcomes: A, B, and C. Three outcomes are got. Okay, in these three outcomes, A occur 4 times, right? If A is occurring 4 times, then 4 by 10 will be 0.4. Is it right? Point 0.4. Fine. Now let us say I am going to test for 1,000 times. I am going to test for 1,000 times. Okay. And the number of outcomes, right? Number of outcomes of A is 400. Okay, is 400. Now what happens if I divide 400 divided by 1,000, then you will be getting 0.400. Is it right? 0.400. Is it right? That is, the result will be 0.400. Okay, these two are same actually. Mathematically, these two are same because there is no value for 0 if it is above point. Is it right? So 0.4, 0.4, both are same because these two will be gone, right? 4 by 10 will be 0.4. But actually, these two are not same. These two are not. Reason is, here you have done 10 test cases, 4 occurrences were there, but here in this case 1,000 test cases, but 400 occurrences were there. Is it right? These two are not same exactly. This is a multiple of it, but still in the real time scenario, this is not same. Is it right? That is what it is mentioned here. Okay, that is what it is mentioned here. That is, see, here the significant figure is 4. That is the number of decimal or number of size of this particular decimals, right? So for example, here in this case 5,400, it is 54 into 10 raised to 2, or 540, all are same actually, but it is not clear. The assessment is not clear. So you need to have a clear representation, because you are going to apply this in a real time, right? So that will be different. Okay, so you have to have a clear assessment when you are doing the mathematical modeling. Okay, fine. The next is dimensional analysis. That is what I told you, right? That is, you have a physical quantities or fundamental quantities. You are converting that fundamental quantities into a derived quantities. That is what is called as the dimensional analysis. So dimensional analysis is the analysis of the relationship between different physical quantities by identifying their base quantities. Based on their base quantity. What is the base quantities? Base quantities means your we have taken area, right, as an example. No, area is equal to length into breadth. That is what your base quantities, right? And based on the base quantities, you are converting that into a derived quantities with the help of the physical quantities, right? So this is what is called as the dimensional analysis, right? Fine. Okay, let us discuss few problems so that you can be able to understand these concepts very clearly. Okay, so let us solve this problem in the next class, right? But still we should know about what is the concept behind this, right? So let us discuss the problem. Describe the role of mathematical modeling in a design engineering. Okay, show how mathematics and physics play a role in designing a lifting mechanism to raise 100 kg of weight to a floor at a height of 10 meters in a construction site, right? The same example we have discussed previously, right? It is created as a problem. Let us solve this problem, right? What will be the what is that? What will be the required power to lift this particular what is that? Your object, right? It is having 100 kilogram of weight, right? That object is having 100 kilogram of weight. Let us discuss that in detail in the next class. Okay, I'll give you the PPT to you, so please try it out. So let us discuss the solution in the Tuesday's class, right? Okay, so thank you.